If b and c are constants for which the quadratic equation x squared plus bx plus c is equal to 0 has two different roots, what is the product of the two roots? Let me read that one more time. If b and c are constants for which the quadratic equation x squared plus bx plus c equals 0 has two different roots, there we go, what is the product of the two roots? So let's maybe start by, let's just make a quick example of a quadratic in its factored form. So if we say x plus 3 times x plus 5 is equal to 0. So what do we know? So when we FOIL this out, we know this value here plus this value here. So 3 plus 5 is going to give us our b, right? So b is going to be equal to 3 plus 5, which is 8. And this value here times this value here is going to be equal to c. So c is equal to 3 times 5, which is equal to 15. And then our roots, which are our possible values for x, are -3 and -5. And if we were to FOIL this out, we would see that this is true because, so we get x squared plus 5x plus 3x plus 3 times 5, which is 15, is equal to 0. So this gives us x squared plus 8x plus 15. So like we said, b is equal to 8, c is equal to 15. And so they are asking for here the product of our two roots. So in this case, it would be -3 times -5, which is also equal to 15. So that's just a recap of quadratics. Now let's actually see if we can solve this. So it says one of the roots is 3. So what does that mean? So if one of our roots is 3, then 1/2 of our factored form of our quadratic should look like this, right? X minus 3. But then we can have x minus 3 times x plus 2. And then we could also have x minus 3 times, let's say, x plus 3. And these will give us different values, I assume, for the product of our two roots. So in this case, we would have 3 times -3, which is equal to -9. In this case, we would have 3 times -2, which is equal to -6. So insufficient. Statement 2 says c is equal to 6. So what are all the ways? Remember, we said c is the product of these two values here. So what are all the ways we can get 6 as the product of two numbers? We can have 1 times 6. We could have -1 times -6. We can have 2 times 3, or we could have -2 times -3. So if we were to write all these out in our quadratic form, we would have x plus 1 times x plus 6 is equal to 0. X minus 1 times x minus 6 is equal to 0. X plus 2 times x plus 3 is equal to 0. And then I'll do this one over here. X minus 2 times x minus 3 is equal to 0. So you might say, okay, we got 4 examples here, so this is also going to be insufficient, but we still need to check, because what if these all give us the same value for the product of our roots? So here, x could be -1 and -6, so -1 times -6 is 6. Here it's x can be +1 or +6, which is 6. Here x could be -2 or -3, which is 6. And here x could be +2 or +3. So in every case, we're always getting product of our two roots equal to 6. Therefore, this statement is actually sufficient, B.